learning and deep learning. It's a very pleasure to me. And before we start, I would like to share a Slido link. So if you have some question during the presentation, you can ask there. And at the end of the presentation, I read and answer them all, okay? My volume is low for you. Let me see. Okay. Okay, so I will start to share my screen, so you can see my presentation. Can you all see my screen now?
Yes, it is visible.
Yeah, we can.
Okay. So let's start. Okay, so can you see my slides too?
Yep.
Okay, fine. So today we are going to talk about deep learning. And for those who don't know me, which I believe that it's most of you, my name is Arnaldo. I am a machine learning engineer at Wildlife Studios. Wildlife Studios is a gaming startup. So we develop games. Maybe some of you have already played some of our games. For example, Tennis Clash, Zuba, Castle Crush, Sniper 3D, one of our famous one. I'm also a Google Develop expert on machine learning. For those who don't know what is it, it's basically a program from Google that recognizes experts in some areas. In my case, I'm an expert in machine learning. I'm very proud about this title because there are experts in other areas like Android, Flutter, and so on. But I'm very proud about this title because there are only a few people with this title. In Brazil, I believe there are only 6 Google Develop experts on machine learning. And I'm also a PhD candidate on deep learning. So that's it. So today we are going to talk about deep learning. Maybe most of you have already heard about deep learning, and the expectation about deep learning is very big. Actually, we can see some news like Google developer an AI that is able to identify X-ray images better than humans, or there is an AI that drives a car better than humans, and something like that. So some people think that deep learning is some kind of the Skynet, but the reality is that we are at the beginning of deep learning yet, so we have a lot to improve. And for example, this is a real output from a deeper network, and we can see that it recognizes. We can see the image that we have muffins and dogs, and they are all recognized by the same from a network. And that's funny, but for us, it's very easy to recognize them different, but for the network, it's the same, all these images. So we have a lot to improve yet. Of course, we have already make good improvements in all areas, actually, especially images, natural language processing, voice recognition, and so on. But we have a lot to improve yet. We are just in the beginning. And actually, in practice, training deep learning is very hard. It's a very time-consuming task. So we're going to spend a lot of time training our models, dealing with our data, tuning your hyperparameters, and it's a very hard task on practice. So that's will be the focus on my lecture. I will talk especially about practice on deep learning. So my story with deep learning starts in 2015. Actually, 2015 was a very crazy year to me because in August I got married. In October I finished my master in science, and in October I also went to London to start a PhD in deep learning. And in December of that year was my first contact with deep learning. So that's a funny story because as far as I remember, when I was in my graduation, I used to hear about neural networks. It was not deep learning by the time, but I used to hear about neural networks. And I remember that I thought to myself that, oh my God, this is very hard. I will never want to learn about it. But when I had my first contact in December of 2015, I felt in love about it. I love it so much. So I remember that in that year, I spent my birthday, my Christmas Eve, and my New Year's Eve studying about deep learning because I felt in love really. So, but it was in December of the 2015. But in 2016, I received an email from my university. I was at that moment, and basically saying the following: "Good morning, Mr. Arnaldo. Your sponsor hasn't paid your taxes yet. If they don't pay, you have to." I didn't have and they also sent a bill of about 12,000 and a half pounds. So that's a lot of money for me. I didn't have this money in my pocket. I didn't have this money in my saving account, so I couldn't afford it. And in the same minute, I answered, where do I sign my withdrawal? How can I drop out the university? So I had to drop out the university and I had to come back to Brazil. But I thought to myself, actually, okay, so now I got back to Brazil without a PhD, without a job. So, but I have a lot of free time. So I will spend my free time studying about data science, studying about machine learning, studying about deep learning, since I love it. So I spent almost the 2016 year studying about data science, machine learning. Here are some courses that I did in that year. These are not all the courses, but these are the most relevant ones. So the ones I recommend you to do too. And that's it. And in August of 2016, I received an email from the company I used to work saying the following: "Hi Arnaldo, we need a freelancer to a brand new project. What do you say?" I had no job. I had no, so I responded, "Where do I sign?" So I started working as a freelancer for that company. And my first project was actually the problem here is we had a webcam in the back of the rear view mirror of the car. So the webcam was supposed to start moving the car driving around. And we want to accomplish two things. First, we want to detect the traffic light. So we need to know where the traffic light is. And later we want to know what's the color of the traffic light. So we want to classify the traffic light image in red, in green, or yellow. So to accomplish this project, basically I start driving around my city at the time, and I recorded 23 videos that about 3 hours. And for each frame that there was a traffic light on the image, I went there and labeled, here's a traffic light, here's another traffic light, and his traffic light is yellow. Here, in the next frame, here's a traffic light, and this traffic light is green. In another frame, here's a traffic light, and this traffic light is red. So I spent about 2 weeks or a month, I don't remember exactly, but I spent a lot of time doing that, but the result was amazing. Are you still hearing me? Hello, can someone hear me yet?
Yes, it's audible.
Okay. So the result was like this. So you can see that my detector, it can detect the traffic light and classify it as red, yellow, or green. So, and you can also see that it can recognize different shapes of traffic lights. Here in Brazil, have different shapes for different traffic lights. So my system was able to detect all of them and classify them correctly. So the result was very amazing. The company liked the work I did, and they extended my freelance contract. And the next project I did was very similar, but now it's for stop sign. So basically, I did the same thing. Since the traffic lights are more they're more equal between each other, and they are all almost equal to each other. So they are all they have all 8 sides, and they are all red. They have a stop right on it, and they are very similar to each other. They are not so different like the traffic light. It was a very easier test. So I just needed one video, about 6 minutes, and I just need to label 70 signs, which is much lower than 5,000 traffic lights, right? So, and the result was like this. So you can see when the video starts that my system was able to detect the stop sign and say, okay, here's a stop sign. Let me show you another examples. Okay. So here's a good one. Now we have stop signs in the both sides of the street, and we can detect both. So okay, that was basically the result. So in all these cases, I did was using machine learning, and then the next project, my freelance contract was extended one more time, and my next project was the car distance. What's the problem here? The problem here is we will use the same webcam that we are using to detect traffic lights and stop signs, but now we want to estimate the distance we are from the car in front of us, but using only the image that came from the webcam. So we have no information from ultrasonic sensor or distance sensor. We only use the image captured by the webcam, and we're gonna try to estimate the distance from our car to the car in front of us. So basically, to do that, I got 3 videos of 10 minutes, and I built a detector using machine learning to detect the cars, and a machine learning algorithm to estimate the distance from the car in front of us. So the result was like this. This is one of my favorite projects. So we can see that we can detect the car and estimate the distance to the car in front of us. I think that's very amazing. So we can detect the car and say, okay, this car is about 8 meters, 7 meters in front of us. I'm not sure if in India you also use meters or inches to compute to measure the distance, but okay. So basically, this is the result. Okay, and after this project, my contract was extended one more time, and the next project I did was the classroom. So basically, the company I used to work on was a company that most of their clients was driver schools. And here in Brazil, when you want to get your driver's license, you need to do basically 2 things. Now, you need to first attend the theoretical classes and practical classes. So in these theoretical classes, basically you need to go to your classroom and you watch the class and okay. So, but here in Brazil, when we're going to attend theoretical classes, first you need to verify your identity using your fingerprint, and then you attend your classroom. And at the end of your class, you verify your fingerprint again. But there was some fraud cases where people in the beginning of the class they verified their fingerprint, but they went to home, and in the end of the class they get back to the driver school and verify their fingerprint again. So we wished to avoid that, and one of the solutions we did was okay, so we're gonna verify the fingerprint, but in the class we're gonna detect people inside the class, and we're gonna try to identify them. So basically, we get about 8,000 images from different classrooms in drivers' schools. And for these images, we did the same thing for the traffic light or the stop sign. For each image that there was people, we labeled, here's a people, here's another people, here's another person, here's another person, here's another person, so on. So we basically did for 40,000 faces, and we also need to label non-faces. But why? But you're gonna ask me, why do you need to label non-faces too? Basically, when you want to, so this is the first thing I want to teach you today. So if you wanna try, if you wanna train a machine learning algorithm, you need to if you wanna teach him what is something, you also need to teach him what is not this thing. So, for example, if I want to if I want to train a machine learning algorithm to detect a face, I also need to show them what is a known face. So that's basically important. And you can also ask me, why do you have too much known faces images than faces images? Because if you think in the real life, the distribution of what is a what's not a face is much higher than what is a face. So we have in the real world, we have much more things that are known faces than things that are faces. So basically, when you are training your machine learning algorithm or your deep learning algorithm as well, you need to represent this real distribution for the algorithm too. So that's very important. So okay, so we trained a face detector, and the result was like this. Okay. So before this machine learning detector I did, we used it to use the OpenCV face detector, the classical one. I'm not sure if you know the OpenCV, but they had a face detector. But the face detector was good, but only for frontal faces. They was not good for all positions that the most case of in a classroom. So you can see that my machine learning detector is able to detect faces in all positions, in frontal faces, in side views of the faces, in back position too. So my face detector was a very good solution that became better than the standard OpenCV face detector. So the result was amazing, and we start using it in the classrooms here in Brazil. Okay, so here you can see some images from this problem. You can see that there is no standard about the position of the camera. There is no standard about the position of the students. You can see a lot of positions for the faces. You can see a lot of problems like occlusions, like the heads down, like very small faces and other ones. But my system was very good to detect them. Later, I will show the results. So after these 4 projects, I was finally hired as a researcher. So I started as a researcher, and my first project was the liveness detection. What is liveness detection? Basically, we talked about the theoretical classes, and in the practical classes here in Brazil, when you want to get your driver's license, when you are going to attend the practical classes, you need to take a picture from yourself, and you need to take a picture from the instructor. So and you verify your identities, right? So, but imagining, let's suppose that you or your instructor can't attend the class, can go to the class, but you don't want to lose your class, your practical class. And sometimes some people, they took a picture from their picture. So basically, instead of I taking a picture from myself, I'm taking a picture from a picture of me. So so it's a fraud, right? So to achieve this project, we had 2,000 images about a real person in front of the webcam and 2,000 pictures about pictures of pictures. So we want to detect that if the person that is showing to the camera is a real person or not. And we did something for that, and the result was like that. So as you can see, when I am in the front of the camera, my system will say that I am okay, I am a real person, and I will reset the analysis. That's because it becomes red again. But since I am in the front of the camera, sometimes it will say, okay, that's a real person. But now probably I will get my cell phone and I will show a picture from myself. So the system will never say that I am a real person. It will never say I am okay. And I also show a video for myself where I am blinking, where I am moving my face. And the system will never say again that I am a real person. And when I get back to the front of camera, we can see that the system will start recognizing me as a real person again. So that's what sliding detection means. You want to know if the person showing to the camera is a real person or not. And this project was very amazing because it teach me something very important lesson. I achieved 99% of accuracy, and it teaching me that basically when you have some machine learning algorithm that or deep learning too that is very good or very bad, you need to inspect it again. You need to be careful about it. So basically, when it happens, there are something wrong with your data, something wrong with your detector, something wrong with something. Because when we deployed this system to production, our accuracy was very lower than that. So I got very good results in our local test, but when deployed to production, the result was very bad. So that teach me that. Okay, so when I entered in that company, most of the projects were based on computer vision, and I introduced the machine learning. And with all these projects, the traffic light, the car distance, the stop sign, the class 1, the liveness, I introduced machine learning to the company. I introduced machine learning as a daily technique for the company, and I think that was amazing. So you're gonna ask me now, you must thinking, okay, so he talked about machine learning, but where is deep learning in this lecture, right? So my story with deep learning in that company started in 2017. They paid the course to me in the Unicamp. Unicamp is one of the best universities in Brazil, and they had a deep learning course, and this course was very amazing to me. I remember that I have already learned about something when I enter in this about deep learning when I entered in this course, but in this course I learned much more about deep learning. I learned about some things that I didn't know. I learned about some techniques. I learned too much about deep learning. That course is very amazing to me. I like it so much, and I like it so much that I remember that I promised to myself that in 2 years I wanted to close the research department of that company. Okay, you may think that this promise is a very big promise, but we're gonna back to it later, and we're gonna see if I achieve it or not. Okay. Okay. So when I got back to the company after that I did the course, I said to myself that okay, I will apply deep learning something right now. So what project can I apply deep learning? Okay. So basically, to apply deep learning, you have two important requirements. First, you must have a lot of data, especially if you want to train your solutions from scratch. So the project, I used to say that if you want to train a deep learning algorithm from scratch, you need a million of data. But if you have 100,000, that's okay, but maybe it will work too. But if you have only dozens of images or data points, that doesn't matter if it is rows in the table or images, okay. If you have only a dozens of thousands data points, maybe it will not be enough. It will depend on your problem. But if you have only 1,000 images or 100 images, it will be very hard to work, especially if you want to train from scratch. So in this project, we had about 100,000 images, 40,000 faces, and 90,000 non-faces. So okay, I will apply deep learning on this project. But we had a very important constraint. That's the second requirement about deep learning. I couldn't use GPU. So using GPU is very important to train your deep learning models because GPU will make it very, very faster. And we couldn't use GPU because most of our systems in that company were deployed direct to the client. So the client use it to run our systems in their computers. So we could not say to our client, okay, you need to use a GPU on your computer now because our systems are deep learning systems, and we could not say that. So we need to train a deep learning model that was able to run in a CPU computer. So that's very difficult, but I trained a lot of machine learning models. I trained a deep learning model with this data, but the result was not good, was not better than we already had. So for my first intuition about was that my data was not enough. So I increased the size of my data. And okay, so I increased the 40,000 phases to 120,000 faces, and the 90,000 non-faces to 180,000 non-faces. So basically now we had 300,000 images. And for this project, I also thought to myself, okay, so this is my first deep learning project in real world data. So I will use this project to test everything I know about deep learning and everything I heard about deep learning. So if someone say that more layers are better or more filters are better, or the dropout rate of 0.5 is better, I will try that. So I tried everything I had heard about deep learning in this project, and I ended up training more than 550 models. So I trained a lot of models, testing every hyperparameter configuration possible. And I actually spent about 4 months training models for this project, but the result was amazing. As you can see, if you compare for our the previous solution using OpenCV or DLive, that's another library for computer vision, our results was about 60%. So basically for each 100% in the classroom, you usually to detect 60 of them using traditional computer vision libraries. With the machine learning, that was the video I showed before, we improved it to 85%. What's a very huge improvement. And using the deep learning solution I developed, we improved it to 89%. So basically we detect 90 out of 100 persons in each classroom. So that is amazing. And you can see, for example, the results of the deep learning face detection I developed. So we can see that my system was able to detect almost everyone in the classroom, even in dark images like this one in the top left corner, the bottom left corner. And I also made some analysis about my deep learning detector. Let me just okay, so I made some. So here is the faces that my deep learning detector was able to detect. So you can see the kind of faces my system detected. So you can see there is a lot of faces with different positions, with different kinds of occlusions, with different image qualities. Like, for example, this one image is very low in quality. This one is very low in quality as well. This one is very occluded. My system was able to detect all of them. So in different kinds of position, different kinds of qualities, and so on. But I also analyzed the errors of my system. So here we have the false negatives. Basically, the false negative was the faces that my detector was supposed to detect, but was not able to detect. So basically, is the faces that my detector could not detect for some reason. I don't know why. I don't know why. So we can see that most of these faces are faces in back position, and maybe this is a good indicator that in my data set, there is not enough faces labeled in the back position. And that makes sense, because if you think in a classroom, most of the faces will be in front of the camera. Basically, only the faces in back position will be about the teacher. And okay, that makes sense. And here we have the false positive. So basically, it is the faces that my detector detected, but they were not supposed to be a real detection. So we can see that there are real false positives, like this one. This is a mouse, and this is a projector. These are real false positives, like the shares too. But we are detecting a lot of faces that are considered as an error. But why they are considered as an error? Because they are not labeled in the data set. So this is an indicator that there are some mislabeling in my data set, and we need to fix that. But there are two cases that I think is very interesting. For example, this face here is a face showed in the notebook of the teacher. So it's, of course, it's not a real person, but it was detected by my detector. I think that's amazing. And this face here, it's a face in a tattoo of someone. So I think that's amazing too. Okay, so after this project, I compared my solution with others great company solutions. For example, here's the IBM detector. We can see that it detects only 1, 2, 3, 4 faces, but it has a lot of positives, like this one in the bottom and this one's in the top, for example. Here's the Google one. It detects only 3 images, but at least it has no false positives. The Microsoft detected 5 faces. The Amazon detect almost every face, but they didn't detect this guy using a hat and this guy in the back of the class. And this is the system we developed. So we were able to detect all of them. I think that's amazing. Okay, so I did this project using TensorFlow and using Python. But in that company, most of the systems were deployed in C++. So after I finished this project, I had to make it work on C++. So that's okay. So I'm not sure if you know, but the TensorFlow is writing in C++, but the Python API is much better than the C++ API. That's very strange, but it's okay. So I had three problems to make this project working on. So first, I had to make it work on C++, using TensorFlow on C++. That would be hard. I also have to make this work on Windows, because the company used Windows, and TensorFlow was originally developed to work on Linux. So that was another problem. And I also had to make this work on the Visual Studio. Probably most of you work with Visual Studio because you are Microsoft partners, right? And and you know that's not very easy to configure a project in Visual Studio. So I had all these problems. But when I went to TensorFlow documentation, there was a page specifically for that. So how to run TensorFlow on Windows using Visual Studio. And when I tried to run on my computer, it worked, for my surprise. But when I tried to use my model in the project that we used to work on, I had a problem. I had this error. So I'm not sure if someone of you know what this problem means. I didn't know true either. And when I received this error, I was like that, because I asked to my boss that I develop a deep learning detector that was better than our previous machine learning solution, and I was not being able to run this on our project, and I was very anxious about that, very desperate about that. but okay, but then I put myself together and I thought, okay, let's try to solve this error. So the first thing is I will try to understand what this error means. So basically what that error means? So basically that error is saying that the value MED is not matching with the value MT value. So what does it mean? Basically, it means the following. Let's suppose that I develop a project in C++, so I have an executable file, and I want to send it to my friend. So if I use the -md solution, that is the default solution, if I want to send to my friend, I will need to send him the executable file plus all DLLs my project depends on. So for example, my project depends on TensorFlow DLL, on OpenCV DLL, and I have to send this executable file plus all the DLLs my project depends on. But some of the DLLs are Windows DLLs. And if the Windows updates, it may crash my program. So the other option is -mt, that in this case, all the DLL code will be put inside the executable code file. So if I send to my friend, I can have sure that my program will work on their computer independently if it has the DLLs or not, or the Windows updates or not. So of course that was our solution when we develop our systems, because we want to send to our clients and we want to make sure that they are able to run it. So I asked in the TensorFlow documentation about how to build TensorFlow on Windows with -mt option, and I found an issue just about it. And that issue was closed. It was opened by Alex Petrenko, and since it was closed, it was a good indicator that it has been solved. But when I was reading about the issue, basically in the end, Alex Petrenko said that, okay, guys, I was able to solve this problem. It was very hard. It was a very hard task, but I was able to solve it. And that's okay. I'm closing the issue. Bye. Basically, he said that. So since I had to solve that problem, I sent an email to Petrenko. So I said, hi, Petrenko, you are the only person I know who was able to build TensorFlow with -mt option. How did you achieve that? And Petrenko answered to me, hi, Arnaldo, it was pretty hard, but you only have to blah, 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 and then blah, blah, blah. Basically, he said a lot of technical things that I didn't understand nothing about it. And, but there was something that he said on that email that I never forgot. He said, however, I don't recommend you to do that. But I didn't have that option. I had to make that work because I said to my boss that I developed a deep learning detector that was better than the machine learning detector. So basically, my days on the company was like this. I think in something, I thought in some solution, and I try and I failed. I think, try, fail, think, try, fail, think, try. So I got stuck in this loop for about 4 months. So you can imagine that after 4 months trying to solve that problem and not resolving it, I was like that. So I was very sad because I thought, oh my God, the company paid a course to me about deep learning. I made something, I improved something using deep learning, and I cannot, and I am not able to deploy it because I cannot make it run on C. I cannot make TensorFlow run on C++. Oh my God, what can I do? But there was one day that I was able to build the project, and I was very happy. You can see how happy I was because instead of taking a screenshot from the, instead of take a screenshot, I took a picture from the screen with my cell phone. So you can see that I was very happy. So I sent this picture to all my friends and say, "Oh, I did it! I was able to achieve it! I got it running!" And I was very, very happy. So at this day, when we were able, a few days later, we were able to deploy the face detector. And in this day was a very important day because in this day, I turned the company I used to work on into a deep learning company. And I think that was a very important goal in my career, and I'm very proud of that. So after this project, I said, okay, we're gonna need a GPU right now. I don't want to train deep learning models on CPU anymore. So I asked for a GPU. They gave me, and we started applying deep learning everywhere. So the first project, the other project we applied deep learning was in fingerprint enhancement. So what is it? Basically, these are images from the original that came from the fingerprint sensor, the original images. As you can see, these images are not good for recognition because they have a lot of noise, so they are not good. And the enhancement process it basically turned this image into a black and white image with almost no noise, and this image is very much easier to identify a person's identity. So we developed a deep learning solution that would receive that image as input and output that image. So basically, our deep learning model, it would learn to paint an image in black and white. Basically, it was that. So we used 120,000 images, and we achieved state-of-art results in that time. We are not a state-of-art anymore, but we achieved state-of-art results. We also published a paper about this method, and our system was able to run at 8 or 7 frames per second on GPU, but in CPU it took about 12 seconds. So we never deployed this system, but that's okay. So the other problem we dealt with was the classification of fingerprint. So if you look to your fingerprint, you probably see that your fingerprint belongs to one of these 6 classes. So why do you need to classify fingerprint? Basically, imagine that you have a 1 million image fingerprinting image data set, and I want to verify a person identity. So why would I compare your fingerprint with all the images in the data set if I can't compare only to the person who belongs to the same class of you? So that's why fingerprint classification is important. We can decrease the searching time by a lot. And we developed a deep learning model to classify the fingerprint. So usually 4,000 images. And we also achieved state-of-art results and 95.2% of accuracy. Unfortunately, we didn't publish that paper, and we are not state-of-art anymore, but it was a very good project. So this was 2 more projects that we did with deep learning. And after this project, we thought to ourselves, okay, let's stop training deep learning model from scratch. Let's start using pre-trained models. So the first project we used a pre-trained model was the in-car. What is it? Basically, there will be a cell phone inside the car right now, and you want to detect the people inside of it, inside the car. So we had only 15,000 images, and we labeled, and in these images there were 18,000 people, and we used the TensorFlow object detection API that has a lot of pre-trained models. So we use a model of that to detect people inside the car. So you can see how difficult this problem is, because after the deep learning solution, before the deep learning solution, we used detectors. And we can see that also in the classroom, there is no standard about the cellular position. Sometimes the faces may be occluded by the driving wheel. Sometimes the face is not showing completely, and it is very hard to achieve a good solution when you use a face detector. Especially in night images, you can see that night images are very darker, and the problems become even harder. So when we start using people detector, we are able to detect almost everyone in the car, even in the dark images, in the night images, and we achieved very good solution. So here you can see that our preview face detector achieved 93%, and we using the TensorFlow object detection API models. We were basically we used three different models that we have a trade-off between accuracy and the time. So, for example, for this model, we were able to detect almost everyone in the car, but it takes about 6 seconds to run on CPU. And this is another model that is able to detect 95% of the people, runs about 7 or 8 frames per second, FPS. Okay, so we are finishing now. There are only 3 more projects that I want to talk about. And this project is actually about my PhD. It's related to my PhD. I'm not sure, but I think most of you must have a passport, maybe. And there is an international standard about passport pictures that they say that passport pictures must obey a lot of requirements. For example, you cannot looking away, you cannot have the hair in front of your eyes, you cannot be eyes closed, you cannot be wearing glasses, you cannot have a varied background, you cannot be with your mouth open, and so on. So there is a lot of requirements that passport images must obey. All the countries that emit passport must obey this international standard, and basically we had a solution for all of these requirements, but one solution for each requirement. And there are some requirements that are more difficult than others. So basically we did 2 things for this project. First, we wanted to know if a person using hat or cap, because if you're thinking using computer vision classical techniques is very hard to verify if a person using a head cap or not. And we also want to segment the images to become it easier to make a processing and other things. So for the head cap project, basically we had about 1,000 negative images, so people that were not using hat or cap, and only 123 positive examples that were from people that were using hat or caps. So do you remember that I said that one of the requirements for deep learning is that you must have a lot of data. So in case when you have just a few data, like in this project, one of the things you can try is using transfer learning. What is transfer learning? Transfer learning is when you get a pre-trained model and you try to transfer the learning of this pre-trained model to your problem now. Maybe the pre-trained model knows something that can be useful to your new kind of data. So in this case, you can use this technique when you have just a few amount of data. And we trained a model for that, and our results was like that. So you can see, for example, this guy, our system is saying that he's not using a head cap with 100% of probability. This guy too. This guy is 99.96% of probability. And here you can see that the system say, okay, this woman has something in her head with 98.85% of accuracy, 92 Actually, it's not just for head or cap, but for everything above of your head. You cannot use anything when you are taking passport pictures. And that was one of my. This model is one of the most confident ones about that I trained. I'm very confident about this model. He's very good, and he achieved very good results. And for the face segmentation problem, basically we want to segment the image in 8 classes. Segment is basically paint the picture using the colors that you want to represent some classes. So we had 8 classes. Let me see if I can remember all of them. Background, skin, beard, eyebrow, head, hair, eye, and clothes. Okay, so I remember all the 8 classes, and we had about 700 images to train a face segmentation, and we developed a solution that was able to segment face images in CPU about 8 frames per second, and our result was like that, and that's our result. So you can see that my system was able to segment the image. Of course, there are some errors, but if you think that we trained this model using only 700 images, I think the results are amazing, because we trained it from scratch using only a few images, and the results I think is very good. So we're gonna use another people, so you can see we detect the clothes, the face skin, the eyes, the eyebrow, the head cap, the bird. We can also detect the bird, the eyebrow, the eyes, the hair, and I think we achieved a great result using only a few images. If we had more images, we could achieve better results. And finally, the last project I want to talk about is the face pose estimator. Basically, using this problem is maybe can we estimate the face position in 3D, the 3D face position, 3-dimensional face position using a 2-dimensional image? So use DLib, that's a computer vision library, to detect 6-8 points around the face, and we use the information about these points on the 2-dimensional image to try to estimate the face position on a 3-dimensional space. So we only have we didn't have any information about depth sensor or distance sensor, nothing like that, but we only use the image and the information about this point to estimate the face position in a 3-dimensional space. So we had 6,000 images with this information, and we trained a system that was able to run in real time using CPU, and the result is like this. So basically, here you can see that my system is detecting the point around my faces, and we have three measures about the face in the 3-dimensional space. Let me show you. So you can see that the pitch is when you make a sign of yes with your head. So when your head is down, your pitch is negative, and when your head is up, your pitch is positive. Also, the yaw is when you make a sign of no with your head. So when your face is turning to the left, your yaw is positive, and when your face is turned to the right, your yaw is negative. And the row is when you turn your head like this. So basically, when your head's turned to the to the right, your row is negative, and when your head's turned to the left, your row is positive. So we only use the information about these points in the 2D image to estimate the 3D position of a face. And it's running on real time in the CPU. I think that's amazing. And okay, so when I, just to remember, when I entered in the company, it was totally based on computer vision classical techniques. And I started introducing machine learning. And after some while, I introduced also deep learning. And when I left that company, basically our project was like this. So we were for sure a machine learning and a deep learning company. And do you remember that promise I did when I finished that course, that I want to close the research department in 2 years? Maybe if I had promised to myself that in 2 years I want to finish all computer vision projects of the company, would be better. Would be a better promise that I could have accomplished. But in all cases, I didn't accomplish that promise, but I think I did a very good job on that company, turned the company into a machine learning and a deep learning company. And I think that was amazing. I'm very proud of that. So to finish, only that 2 projects about the classroom and the people detector inside the car, they evaluate about 270,000 classes per month, and almost 2.2 million images per month. So it's basically 1 image per second, and I think that's amazing. So to finish, also I would like to, if I had to give someone some tips about about deep learning, about the things I did. First of all, the language you must learn is Python for sure, because most of the frameworks are written in Python. They have a good API for Python, so the Python is a good language to learn about deep learning. About the framework, I think my recommendation would be TensorFlow 2.0. I use it to recommend Keras as well, but the TensorFlow 2.0 become a great framework. It's very similar to Keras. Actually, the TensorFlow 2.0 re-implemented Keras from scratch, but they also added some nice features to it, and I think TensorFlow 2.0 is a great framework for today, and it's the best option that we have as an open source option for the community. And if you want to deploy models, my suggestion is try to deploy your models as an API, because it makes the process very more simpler than what I did, trying to make the system run on the CPU and deploy to the clients. So try to deploy models as API to become more easier to facilitate the entire process. And to finish it, I like to let a sentence. So this is our Abraham Lincoln sentence that basically I think that is totally related to data science and machine learning and deep learning, because he said something like, if I had 6 hours to chop down a tree, I would spend 4 sharpening my axe. So I think that's totally related to data science, to machine learning, to deep learning, because there is basically a joke about deep learning that says the winner of a competition of deep learning is not those who have the best model, but those who have the best data. So you need to spend a lot of time verifying your data, verifying if it's good enough, if the quality is good enough, if the integrity of your data. And I usually spend 80% of the time training a model, expecting my data, and only 20% actually training and deploying. So that's a very good advice. Spend the most of your time training a deep learning model, verifying your data, being sure that it's good for your problem. Then after that, only after that, you're going to start training and thinking about deploying your model. So that's it, guys. If you want to know more about me, there is also my website. You can send me an email on my Gmail too. My GitHub page, let me show you. So basically, this is my GitHub page. There is a lot of projects about machine learning and deep learning. in English and in Portuguese too, but there's a lot of things about machine learning, deep learning that you could think it's useful for you too. So if you want to follow me, that's my GitHub page. I also write about deep learning and machine learning on Medium. So you can also follow me on Medium. So I usually write about deep learning and machine learning in Portuguese and in English. There are also English content, and there are also some explanations about some projects I did. And you can also follow me on Medium. Here's my website where you can find more information about me, and you can also find information about the projects I talked in this lecture. And my YouTube channel, if you want to follow, subscribe to, you can find also the videos I showed in this talk. So I think that's it. If someone, what's our next steps now? I think if someone asked something in the Slido, I could on that now.
Thank you, Arnaldo.
That's okay?
The session was very insightful, and I feel like I will try few of your projects to do by my own by myself.
Someone?
Okay, I will try to do few of your projects by myself. Okay, those projects were really
Can
nice.
I answer?
Yes, you can answer. There is a question in the chat section.
Let me see. Should I?
Yes.
It's okay to answer the question now? Can someone give me some feedback?
Hello, am I audible? Hello.
Okay, so I will answer the questions.
Hello.
Anyway, so let me see. Hello, sir. Can you please share how you collect the huge amount of data for your projects? Yes, I cannot share the data, of course, because I even work on that company anymore. But basically, most of data, since we have driver schools at our clients, they usually share the data with us. So basically, most of our data was collected from our clients by themselves. And we also used lots of open source data sets, and like the face detector and other ones. And yes, basically that's it. So or we got our data from our clients, or we got our data from open source data sets. And how did you solve the MT problem anyway? Okay, so I wrote about how I solved it on Medium. So you can check my Medium to where I can explain in details how I did solve that problem. So I wrote a Medium post about it. So you can, if you wanna try, if you are interested in achieving that too, you can read my Medium post. It's in English. But I also have this GitHub repository that can help you. That is can help you as well. So you can find detailed solutions in Medium and the repository on GitHub. So okay, I think that's the two questions. Let me see if there are another one. I have no experience in computer vision. How do I develop and deploy a model to detect whether a person is wearing a mask or not in real time? Person is passing through an entry point, say entry to a shopping mall. Okay, so first you need to define what kind of problem you want to achieve. Basically, you have two options in this case. Basically, you have two options in this case. You can deal with this problem as a classification problem. So we're gonna have a lot of frames about people with wearing a mask or not, and we will label these frames, and we will try to classify each frame in positive or negative cases. So in the other case, you can deal with this that problem like a detection problem. So we can, like I did to the face detector, you can label some people wearing a mask, and you can also label some people not wearing a mask. And you're gonna train your detector to detect people with a mask. So you can, I think you can try to solve this problem and use these two approaches. Frames as image, frames as an image. I think in this case, in your problem, you don't need information about the time, so you don't need to you don't need to take some short clips about your data. You can deal with your frames as individual ones, so you can use frame as images. Someone else? Okay, guys, so to finish, I'm very thankful for that. It's a pleasure to me to be talking to you right now. And that's it. So follow me on GitHub, follow me on Medium, and send me an email too, and we can keep talking, keep in touch.
Thank you, Arnaldo. The session was very nice.
Thank you all.
Thanks for sharing your experience. Okay, I hope that our participant got some insight from that.
I hope you like it.
Yeah. Thank you very much. Thank you. Okay. I think I will end this this session now. Okay. Thank you. Thank you everyone for joining us.